Hi, my name is Mike Amundsen, and this talk is Designing APIs with OpenAPI. Now, first, this is me. This is how you'll find me in LinkedIn, GitHub, Mastodon, X, any place where there's activity going on. LinkedIn is probably the best place, and I'd really love to connect with you. I tell everyone on all of my talks, most of the things that I present are things I learned from someone else, and I would love to learn from you. I would love to learn what's interesting to you, what's challenging, and what kind of things you've thought about and are willing to share with others. So please connect with me here at this moniker. So we're going to talk about designing APIs with OpenAPI. What does that really mean? Really, this is a talk about design. This is about designing APIs in all its aspects. And OpenAPI is a fantastic format to help us do great designs with less effort. And that's what we'll be focusing. We'll be focusing on what I call design assets. What does it really mean to have a set of design assets for your API? Prototyping, and then how to build using OpenAPI, defining paths, components, and then finally, a very important element in the story, modifying your API in production. Most of the changes you'll make to the API, most of the editing to the code and the layout and everything else will happen after it's been released. This is especially true for popular APIs. So we'll talk about that very important element of designing for modification in production. So let's get started. Let's talk first about this notion of design assets. What do I mean by design assets and why are they important? Design assets are essentially any resource that's created or used in the process of designing your API. Now, design assets make lots of sense with all sorts of products. You think about designing the packaging for consumer goods, for food packaging. Think about designing a car and all the assets you need. You need blueprints and color swatches and all sorts of things. Designing clothes. Design assets are really, really important because they really make up all the different parts of how you see the product you're building. And that's going to be the same with APIs as well. You're going to need design assets. So what kind of design assets do you need? I talk about three key assets every API needs. That's a story, a diagram, and a vocabulary set. Story, diagram, and vocabulary. So here's an API story. This is a simple text document with just basic elements. A one-line purpose. This service allows users to keep track of important people or whatever it is. Often it's the reason we're doing this. The action elements, all of the things that we need to be able to do. What are the problems we're trying to solve and how are we solving them? Create, filter, remove, update, all sorts of things like that. And then there's also the data we're going to share back and forth. The name, given name, family name, telephone, email. Notice, by the way, there's no mention here of URLs, of HTTP protocol, of methods, of JSON formats, of XML, nothing like that. This is just plain text capturing important information. Sometimes there are rules. Every ID needs to be unique, so on and so forth. But this is the story. This is the reason we're doing it, the actions we're taking, and the data we're working with. Now, it's good to have a text document, but that's not the only document we need. Many people don't think in text, they think visually. So a diagram is really, really important. So this is a diagram of that same story. Now, notice this diagram is not maybe the typical diagram that you've seen before. This is a connection diagram. This shows how you can get from one step to another, but it's not a navigation. It says, you know, if you're at the home, you could go to the collection of persons. If you're at a collection of persons, you could go to a single item. You could read it. And then if you're an item, you can do an update and so on and so forth. It says what's possible. It sort of gives you a map of the landscape. And it's really important because there are lots of people who think in this way, think visually. They'll read this text, but they'll grasp this much quicker. Most studies say that our brains actually memorize in pictures, not in characters. Now, along with the story and the visualization, the diagram, we need a list of vocabulary. So this vocabulary document lists all the things like resources or states, the home page, the collection of persons, the single person, all of those actions we were talking about before. This rendering is a little bit more formalized. And I talk about ideas of containers, but you might think of them as objects. There are all these properties like ID and family name and given name, and together they make up a person, which is a person record. So these three elements of the story are really, really important. The API story, because the story gets shared, it's accessible and repeatable. Great thing about a story is that everybody can participate in that story all throughout the organization, from the person who was just hired today to the most senior individual in the organization. There's also the API diagram, which displays interactions, shows how things are connected. And that's really what we're doing with APIs, right? Is we're connecting. And then finally, this idea of a vocabulary, all the magical words that we'll use, field names, object names, resource names, all those things become part of the vocabulary. So story, diagram, and vocabulary, that make up our design assets. Now let's talk about prototyping your API. Why do we prototype and why is it important? What is it? It's a preliminary model of something, especially a device or a machine or something else which is going to be copied. We're very familiar with user interface prototypes, as you see here in the slide, but we need API prototypes as well. Prototypes let us build something that looks like the real thing, but it's not. It's a facade. It's kind of fake. You can think of it like a movie set or a stage play set. And it allows people to sometimes even interact with that prototype before we spend a lot of time and money on production. Think about prototyping a vehicle, building a vehicle. It's going to be incredibly expensive to build thousands of vehicles and sell them. So we're going to spend a pretty good amount of effort building the prototype and making sure it drives correctly and that behaves the way we want. So why use prototypes? Because they're inexpensive experiments. When you can reduce the cost of creating a prototype, you're more likely to try to say, you know what, maybe we should try putting the field over here, or maybe we should change the format from JSON to CSV. We can try things and experiment. We're more likely to explore when it's cheaper to do. And that's really, really important. We can also explore details instead of just saying, well, and then there'll be an object here and we'll pass it from here to there. We can populate that object with the properties it needs or the actions it will need next and test that out. We can show that to our colleagues because prototypes are made to be tested. That's really why we create prototypes. Prototypes are a way to experiment, explore details, and then especially test whether or not this is going to solve the problem we're supposed to solve. Does this really make it easier to keep track of important people? This person API needs to be adjusted. Now, I may need to explain the diagram here a little bit, just to give you a sense of what's going on. And this is a sewing metaphor. So you can think maybe you're just about to do sell your company or go public, and you want to go to a big event, a big celebration. So you need a suit or a dress or some other kind of very expensive gown or outfit for this party. Well, if you're going to have a custom outfit made with very expensive material, the very first time someone fits you for the outfit, they're not going to use expensive material. They're going to use muslin. They're going to use cheap material. That's a prototype. And they're going to make sure they cut all the pieces correctly and so that it fits in the prototype. And then once everyone's satisfied, they'll move on to the expensive outfit. So you can think of your prototypes as the muslin or as the test before the final outfit. Okay, with that background in mind, this notion of digital assets and prototyping, let's talk now about actually using OpenAPI to create our prototype space. Now, first of all, OpenAPI wants us to collect some basic information, such as the version of OpenAPI. There are a couple. Version of information about our own API. This is version 1 of the person API, and you see a little description there on the screen. And then we want to connect to a server, a prototyping server. They're called mock servers when we're talking about APIs, but it's really a prototyping server. And you can see there'll be some more material we'll work on, paths and components. That's actually the main material. So this is the basic shared information about your API. It includes a version, the title, and the description. And the title and description are especially important today. Now that we're talking about so many AI chatbots or MCP servers that might be using your API, they're going to use the title and description as important information in whether or not they should select your API in the process. There are some other elements we've already talked about: servers, paths, and components. And we'll get to that in just a second. So that's the basics of our prototype. What is the info block? What is the version, title, and description? And where is my mock server, my prototype server located? Now, I like to start out with dealing with the components and the really operational elements of building up my design in OpenAPI. This is where I'm going to supply things like parameters, input and output parameters, response bodies, request bodies, all these important elements along the way. And parameters is one of the first ones. Every parameter, such as something that will appear in a query string or in the body of a post or a put, needs to be defined. It has a name, it has a location. In this case, the name of the parameter is name, because we're going to do a filtering search, and it's going to appear in the query, not in a message body. We've got a description, we've got whether or not it's required, and a little bit of information about the schema. Notice especially that I've included an example of what the query string name might look like. Examples are extremely important. They're important for generators, SDK generators, server generators, but they're also important to AI chatbots because they provide a lot of context or information. Notice I've got both example and description. Those are very, very important because they will be used both by machines that are going to generate SDKs or servers or by chatbots. Now, another element besides parameter are the actual objects or the items that we'll be using and passing back and forth. So you can see here a person item, which is the type object and has the properties of ID, name, and email. And each one of them have what? A description and an example. Description and example are very important. Now notice also that I have a person item, which is a type object, and then at the bottom, I have a person collection, which is a type array of items that points to the object person item. This is a really good way to build up your prototypes very, very quickly. Define the individual item and then define a list of those items so that we can move them around. Notice again, every property has a type, like a string. And they all have strings here, but at least one of them should be changed to email. So the stronger you type the design, the easier it is to generate. Now, another one is the responses. So every time we make a request, we're going to get a response. So every response has a media type. In this case, I'm actually showing a generic error response, and that error response points to an error object in application JSON. And notice, again, it has a schema that points to the container or the object that I'll be using. And don't forget that description, that all-important description, because the AI, again, will use that as well as other SDK generators. And then finally, there's request bodies. So responses are what we get back. Request bodies are what we send for things like post and put and patch. And again, you'll see the same kind of thing. Important properties are description, whether or not an item is required, the content type, and any reference schema. Notice that I'm referencing schema in two different locations because this particular request body could be sent as application JSON or as a URL encoded form information. They both use the same object, the person object, but they use different formats on the bodies. And that's how I account for that as well. Now that means you can support more than one content element, which is really, really important in flexible APIs. So we've talked about the notion of the component section holding all of the key building blocks, and I've focused quite a bit of time on that. So organize your OpenAPI definition there. Improve the consistency of your API design by using these components over and over again. And those components are parameters, schemas, responses, and request bodies. Every single one of them has an important message or an important aspect that's going to make it a powerful design tool. This makes it easy in the future to modify your design You can modify a request body in one place and it percolates into every place that it needs to be used. All right, so we've built up our components. We've got our basic information. Now the fun begins. This is the part everyone thinks about when they're thinking about designing an API, and that is the paths section. Paths are really the heart of OpenAPI documents. Paths are literally URL markers, and you can apply multiple actions to the same URL, actions such as get, or post, or put, or patch, or even delete. So you'll find a top-level entry for each URL, each path or resource. Remember, we had resources in our design assets. And then you're going to find one or more HTTP methods for each individual resource. So the same URL can have multiple methods. And then each of those methods has parameters, request bodies, and responses. Now here's a pretty good example of the home resource. There's the path, which is just a single slash in the colon you see at the top. And then you can have a get action, which has got an operation ID and a summary, which is a description, as well as a tag, which explains what it's about. And then we've got parameters and responses. Parameters are a tag. In this case, it's a header tag. We didn't talk about header tags, but it's just another kind of parameter. And a 200 response, and a default, if it's not 200, that goes to an error. Here's another example. With a start resource that has a post method applied, ID and summary, parameters, request body, and responses. Notice that there's been both an ID and a summary here. We used both of those for the AI as well. AI will use operation ID as a key element. Here's another one, which is a work in progress. Notice there's a placeholder identifier in the path. Same everything else. We've got parameters such as the identifier and the E tag and responses as well. All of these are path definitions. And you'll note each one of them, as I go back through them, is built up out of the components that we created in the very beginning. All right. So let's talk about one more element of OpenAPI design, and that's modifying it after it goes into production. Maybe you've done your prototyping, you've created something that goes into production, but now you're getting requests to make changes. Modifying your API in production is actually a very, very important thing because it helps you keep up, helps you take advantage of things, but there are a few key rules. We need to think beyond simple versioning of version 1 and version 2. The rule is first, do no harm. Never release an update that's going to break some existing client application. People invest a lot of time and effort in creating those apps. Make sure you honor that. There are 3 rules then for modifying production APIs. You can't take anything away. If you promised a URL, it still has to be there. If you promise some data coming back in that response, it still has to be there. You can't redefine the meaning of elements. If you created a parameter component that says it's named P and it represents the number of pages, you can't change that P to represent the number of people. You can't redefine the meaning. That's going to break somebody. And finally, everything you add is going to be optional. If you've got new return values, they're optional. If you need new input values, they're optional. If you have a new step in the process, in the path to completion, that has to be optional. So don't take anything away, don't redefine anything that's already there, and make all additions optional. And you can ensure success by making sure that you test and deploy your modified APIs using the same tests that you did the last time. In other words, don't write new tests to cover the old material. Use the existing tests and write new tests to just cover the changes that you've made. Don't replace tests. Support reversible releases so that if you put a release in, you can take it out if there's a problem. There's this difference between what are called Salesforce releases and AWS releases. Salesforce always releases a brand new API and keeps multiple running at the same time. AWS releases only one API and makes sure it's always backward compatible. You need to make your choice. Okay, let's do a quick review. We've talked about the notion of design assets, of story, diagram, and vocabulary. We've talked about the importance of prototyping your OpenAPI with a muslin, with a prototype so that it can be tested. We've leveraged all the components to build up your OpenAPI design document. We've talked about defining paths and methods that use those components. And we talked about the importance of doing no harm, no breaking changes on modifying your API in production. Now, there's just one more thing that I'll leave you with, and I think it's a really good lesson to keep in mind from Don Norman, the author of Design of Everyday Things, sort of the father of human-computer interaction. Good design is actually a lot harder to notice than poor design. That's a real eye-opener. People will notice if it's not well designed. They may not notice if it was well designed. So get used to the idea that people don't notice how good your work is. That kind of means you're probably doing a great job. And that's designing APIs with OpenAPI.